So today we'll be looking at the topic Surd. The content outline: 1, we'll be looking at what Surd is. We'll understand what a Surd is. We'll identify Surd. We will now learn how to change Surds to its simplest form. And then we'll also learn how to write simplified form back to its original expression. First of all, what is Surd? A surd is an irrational number that is expressed using a root, like a square root or a cube root symbol. I just gave you an example. Root 8 is a surd, root 42 is a surd, root 72, root 18, and so on. I also want you to understand that root 4 is not a surd because 4 is a perfect square. So the square root of any perfect square is not a surd. For example, root 16 is 8, so therefore 16 is not a surd because it is a perfect square. So surd simply means when you have the non-perfect square and it is being expressed using a root, then it is surd. Let's come over here and identify which of these numbers are surd. The first one is 1 to 1. Root 1 to 1 is 11, so therefore 1 to 1 is not a surd. The second number is root 48. Root 48 is a surd because 48 is not a perfect square, so we'll tick that. The next one is root 59. It is also a surd because 59 is not a perfect square. Now, what of root 81? 81 is a perfect square because 9 times 9 is equal to 81. So no, root 81 is not a surd. And the last one, root 141. Root 141 is a surd because 141 is not a perfect square. Let's look at how to change surd to its simplest form. And these are the steps. Step 1, we have to prime factorize the number under the root. Step 2, we'll group the prime factors in pairs. And our final result will be product of the grouped numbers times the square root of product of the ungrouped numbers. So let's get to solving. Remember, the first step is we should prime factorize the number. Now I'm going to prime factorize this number. I have 18. 2 will divide to give us 9. 3 will be 3. And 3 will be 1. Then we will group the prime factors in pairs. So I can't group the 2 to any pair because it's just there. But I have these 2, so I can group them in a pair, and then I have 3. Now my final answer will be product of grouped times square root of product of ungrouped. Now there is no need for the product because for the product of grouped, the only grouped we have here is 3. So my answer will be 3 root of product of the ungrouped. The ungrouped I have here is 2. So therefore we can say that the simplest form of this root 18 is equal to 3 root 2. So this is our answer. Let's move to the next question. We are asked to simplify root 72. So let's prime factorize 72. So I have 72. 2 will divide to give me 36. 2 is 18. 2 is 9. 3 is 3. And 3 is 1. And then the next thing I'm going to do is group these prime factors in 2. So I'll group this, and then I'll have 2. This one is on its own, and I'll group this, and I have 3. Now remember, the formula is product of grouped. The formula is product of grouped prime number times the square root of product of ungrouped. So product means multiplication. So the grouped prime factor we have here is 2 times 3, that is product of the grouped, then times square root of the product of the ungrouped. The only ungrouped we have here is 2, so I have 2. So 2 times 3 is 6 times root 2, which is equals to 6 root 2. So therefore, our answer to this question is 6 root 2. Let's move to the next question. Looking at this, you say that this looks like a simplified surd. But there is a problem. Yes, it is simplified, but not completely simplified. What do I mean? This root 8 can also be simplified. So what am I going to do? I'm going to leave the 3 out of the business and focus on 8. So let me factorize 8. So I have 8, 2, 4, 2, 2, 2, and 1. Now let me remind you that 3 root 8 is something at 3 times root 8, right? So I'm going to group this. I'll have 2, and then this I can't group with anything. Remember, the formula is product of grouped times square root of product of ungrouped. All right. So from this, our grouped is 2 times our ungrouped square root of 2, which is 2 root 2. And this is for root 8. Now, if we replace this root 8, remember we have this initially 3 times root 8. Now we have reduced root 8 to be 2 root 2. So that means I'll have 3 times 2 root 2. This 2 root 2 is root 8. So that will be 3 times 2 will be equal to 6. So our answer will be 6 root 2. And then the next question, which is similar to what we have before, we have 5 root 27. Someone might say, okay, this looks like a simplified surd. Yes, it is simplified, but not completely. So first of all, we have 5 here. So we don't have any business with 5. It's already there. Then we'll now focus on 27. So let me prime factorize 27. So I have 27. 3 would divide to give me 9. 3 would divide to give me 3. And 3 would divide to give me 1. So let me group. I'll have this 3. Now remember, the general formula is product of grouped, and the grouped here is 3 times square root of product of the ungrouped, and product of the ungrouped here is 3. So that means that root 27 has given us equal to 3 root 3. So therefore I can replace this to be 5 times 3 root 3, and this will give me 5 times 3 is equal to 15 root 3, and this is my final answer. Now I want you to always remember the formula, or should I say the expression, product of group times the square root of product of the ungrouped. Let's move to the next outline content, which is writing a simplified surd as an original expression. So most times the simplified surd can also be converted back to its original expression. So how is this done? Just like we have on the screen, that if you have a root b, then changing it to its original form is the square root of a squared times b. So let me show you how that is. So let's say that this equation is the same as a root b, right? Where a is equal to 5, and then b is equal to 2. So how do I change this to its original form that actually gave us 5 root 2? And the general formula is all square root a square times b. So this is all square root a square is 5 square times 2. And this will give us the square root of 5 square, which is 25, times 2, and that is equal to root 50. So that simply means that root 50 was simplified to give 5 root 2. So the next question, and the next question say we should rewrite the simplified surd to its original expression. So comparing this to a root b, then a is equal to 2 and b is equal to 7. So the general formula to do that is all in square root a square times b, and this will be all in square root 2 square times 7, which is equal to 2 square is equal to 4 times 7, and 4 times 7 is 28. So that means that root 28 was actually simplified to give us 2 root 7. Thank you for watching the video. Don't forget to click the link in the comment section to access the form quiz on surd. Test yourself and see how well you actually understand this topic. And lastly, don't forget to like, subscribe, and comment in this video. Thank you so much.
Be whoever you want to be.